Hey guys, in this video we are going to talk about solving logarithmic equations and evaluating logarithms. Before we get started with that though, we have this one concept that just sort of had to be thrown in here somewhere, and that is the concept of a common logarithm. In other words, we abbreviate this to common log. Frequently we don't say the whole word logarithm out, sort of like it's not written in a function. So if you say log in math, everyone knows that you're referring to a logarithm. And the common logarithm is a log with base 10. And because this is considered a common log, the most common one that we use, you don't actually have to write the 10. It's sort of like if you wanted to multiply x times 2, you need to write 2x. But if you wanted to multiply x times 1, you could just write x. Because if you don't use another number, I know you're just talking about a singular x. Well, if you just write the log of x, I know they're referring to the log base 10 of x. Okay? So these two expressions are exactly the same as each other. In terms of what they mean, they just look a little bit different. So if you want to write a log with base 10, you don't have to write the 10. And just like you don't have to write the 10, neither does anyone else. So you're going to sometimes be presented with problems where the base isn't written and you're going to be like, I don't understand, like what in the world? But if you remember what a common log is, you'll know that essentially there's an imaginary 10 there. And if you want, you can go ahead and write that 10 in to help you out. Because of this common log, we also will notice that there's a log button on a graphing calculator. It's along the left side. It just says log. If you were to type this in your calculator, it doesn't give you the opportunity to type a base. It just like opens up kind of a set of parentheses and lets you type something in. So if you were to type the log of 6, you can't choose a base. So that would be telling you the log base 10 of 6. And it would give you the answer like that. So just so y'all are aware. Now that we've done that, we're going to go ahead and evaluate some logarithms. So this stuff is going to be hard, again, if we don't have a conceptual understanding of logarithms yet. So please make sure you are coming into this video understanding what a logarithm is. And if not, go watch a prior video. But once you understand what a logarithm is, this slide shouldn't be too different from what we've already done. So let's just start and look at number 13. Numbered this way because the prior slides had different numbers. I know we don't usually start with the slide 13 or question 13. Well, anyways, so this is saying the log base 7 of 49. And remember that a logarithm is asking what power does it take for me to get from my base to that number? So what exponent takes me from 7 to 49? Sometimes people like to rewrite this. They like to think, okay, what exponent takes me from 7 to 49? You're essentially converting there from log form to exponential form. There was no right side of this equation, but I could think of that as a question mark. You can also represent these as variables, right? Question marks and variables are the same thing. They're both just unknowns. So you could go ahead and throw an x in there to help you solve this and imagine that you're looking for an exponent. You don't have to rewrite it in exponential form if you don't find that helpful and you think you can do it fine without that. But it might be a good stepping stone as you get used to these types of problems. But whether you're looking at the log function originally and you're just saying, how do I get from 7 to 49? Or you're looking at 7 to what power is 49? It's essentially the same thing. So what power do you have to raise 7 to get to 49? Well, you raise it to the second power. So my answer is 2. If you're ever not sure what power, especially with some of these problems like 17 and 18 down here, you're going to be looking at slightly bigger powers. If you're ever not sure, start with your base and see how many times do I have to multiply it times itself to get to my answer. So in this case, if I multiply 7 times 7, that'll already give me 49. So we don't have to go any further, right? But let's say this wasn't 49. Let's say this was 343. Then I would have to multiply this times 7 again to get there, right? So you basically can just keep multiplying the number until you get there. You can also sort of guess and check in your calculator. If you're not sure, you can type in 7 squared and see what that is. If it didn't match, you could type 7 to the third, 7 to the fourth. Okay, 2 different ways to go about it. One is sort of more like methodically, and the other is just like a guessing check using technology. The more you're able to do this in the head, though, the better sort of better conceptual understanding of math you'll have. So I personally recommend that for your long-term well-being, you go ahead and think about it like this by hand and double check in a calculator if you need to. Looking at number 14, this one here, this asks, how do I get from 3 to 27, right? What exponent does it take to get me from 3 to 27? I personally know in my head that 3 cubed equals 27, so 3 to the third power. And all you have to do here is write that exponent. That's all the log is asking, is what's the exponent that takes me from 3 to 27? But again, if it helps you to rewrite it in exponential form first, I could say, how do I get from 3 to 27? Right? And that might help you sort of see it and visualize it better and just in a more familiar way while you start to get used to logarithms. Our next question, number 15, says the log of 100. There's no base written here. Oh, what do I do if there's no base? I can't solve it. Like, what am I getting from what value to another value? Oh, wait, on the last slide, I learned about common logs, which is a log with base 10. And if the base is 10, I don't even have to write it. So what they meant must be log base 10 of 100, right? So the question is, what exponent takes me from 10 to 100? Well, that exponent is 2, right? 10 squared gives me 100. So that's my answer. The log of 100 is equal to 2. Number 16, this is asking me 12 to what exponent gets me to 1. Okay, so how many times do I have to multiply 12 times itself to get to 1? I'm not convinced that's ever going to happen. 12 times, just 12 to the 1 would be 12, 12 to the 2 would be 144, 12 to the 3 would be some even bigger number. How do I get to 1? Oh, I have to go back to my exponent laws, right? Thinking back to that whole unit we did on exponents. Again, that's why they're back to back. They are super related to each other. That's why I emphasize the importance of the exponent laws so much. Anything to the 0th power is 1. So if I'm trying to get from a base to 1, I'm always going to have to raise it to the 0th power. So I know that that expression, the log base 12 of 1, is equal to 0. We are now moving on to number 17. So log base 2 of 64, what is that equal to? So here I am trying to, why is this not writing? Oh, I'm on eraser, that's why. Okay, log base 2 of 64. So how do I get from 2 to 64? 2 to what power gets me to 64? And that would give me my answer when I figure out that question mark. Well, let me start multiplying 2. To get from 2 to 64, I'm going to have to multiply quite a few times. So in my head, I'm thinking probably at least 4 times. If I multiply 2 times 2 times 2 times 2, all of that is going to give me 16. So that's still not big enough. So let me try one more time. At this point, if I multiply times 2 one more time, that would give me 32. That's still not enough. So I'm going to have to multiply one more time. If I multiply that many times, and double check in the calculator, that'll give me 64. So what it took was 2 times 2 times 2 times 2 times 2 times 2, right? That is a total of how many 2's? 1, 2, 3, 4, 5, 6. 6 2's. I had to multiply 2 times itself 6 times to get to 64. So the exponent, this question mark, is essentially 6. And what that tells me is that that is the answer of my logarithmic expression. And last but not least, I have log base 3 of 243. So I'm looking at how many 3's do I have to multiply to get to 343. Again, I'm thinking probably at least 4. Well, 3 times 3 is 9, times 3 is 27, times 3 is 81, not quite there, times another 3. Oh, that gets me to 243. So what color was that? Or what color was that as I'm changing the color? How many 3's was that? 1, 2, 3, 4, 5. Since I had to multiply 5 times itself, since I had to multiply 3 times itself 5 times, the answer there is 5. Again, remember the answer is just always the exponent. Now, that's just sort of a summary page. On this page, we are going to continue solving logs, but now we're not just evaluating a logarithmic expression that has a numerical answer. We have an equation with a variable in it. So you'll notice each of these examples has an x in it, but the x is located in different spaces. So again, it's really important to understand conceptually what a logarithm is asking and to be able to convert it into exponential form in order to make sense of these problems and solve for x. It's not going to be solved the same way as other equations where you can just do the opposite of what is on the page. I mean, essentially you can do the opposite, but in doing the opposite, what that means is the opposite is just to write it in terms of an exponential. So it's not like I can just take like the log root or divide by the log. Oh, I see that sometimes. Sometimes people try to divide by log. That is certainly not a thing. So try not to make that mistake. Learn from past students' errors. Anyways, so again, let me think logically. Well, number one, it says log base 3 of 9 equals x. So this is actually really similar to the last problem, right? Before it was a blank, now it's an x. We can figure out what x equals to. That's just going to be my exponent. So what exponent gets me from 3 to 9? Well, I have to square 3 to get to 9. So x would just be equal to 2, right? And if I want to rewrite this in exponential form to make it easier, right, I'm thinking log base 3 of 9 means how do I get from 3 to 9? I raise it to the x power, right? So that helps me write it in exponential form, and then I can see, oh yeah, 3 to the second power would give me 9. So x is going to be 2. When it comes to x being located in other spots, converting into exponential form is even more important. So here I'm asking, 2 to what power gets me to x? And that power happens to be 16. So 2, how do I get from 2 to x? Well, I raise it to the 16th power. Okay? So this is something that might have been hard to conceptualize looking at this expression here, but now that I see it in an exponential, I'm saying x just equals 2 to the 16th. And that is something you guys can just type in your calculator. And I'm going to go ahead and type it in my calculator really quickly because that's going to be a big number. I think it's 35,000 something, but I'm just going to type it in just to be certain. Oh, not 35,000, 65,000 something. So 65,536. That is the value of x. Moving on to number 3, again, this x is now the base. So again, if the x is on the side with the logarithm, you're probably going to want to rewrite it in exponential form, or else this could get really complicated. So I'm going to go ahead and say, so how do I get from x to 125? Well, I have to take x to the third power. So if x to the third equals 125, there's 2 ways to approach this. I wish I'd written this a bit higher. I'm actually going to write that up here to give myself a little more space, just rewriting. Okay, the first way is just thinking, okay, what to the third power gives me 125, right? If you have a solid understanding of math and exponents and you're going to have like this background knowledge of cubes and squares, then you might know immediately that 5 to the third power gives you 125 and be able to answer it like that. If that's not the case and you have a number on one side and x to an exponent on the other, this is just solving it like any other equation that has an exponent in it, right? If you have x squared, how would you get x by itself? You would take the square root. Well, if you have x cubed, the way you get x by yourself is you would take the cube root, right? So I can just cube root both sides. The left gives me x. I can type the cube root of 125 in my calculator and it would give me 5, okay? So again, 2 different ways to do this. It's probably going to be faster if you do have that sort of background knowledge on exponents and you have a lot more of them just sort of committed to memory. But if you don't, use your calculator to your advantage as you start to build up that stronger understanding of exponents. Anyways, let's go ahead and switch a color as we move on to number 4. So number 4 says the log of x equals 4. My first step here is thinking how can I rewrite this, right? There's not enough information. There's only 2 things. Remember that if there's no base, I'm talking about a common log, which always means base 10. So I'm actually looking at base 10 of x is equal to 4. So rewriting that into exponential form, I'm saying, how do I get from 10 to x? So what do I do to get from 10 to x? I raise 10 to the 4th power. Okay. Yeah. So this is another one where I And it kind of lucked out because I just have x is equal to this numerical expression. X is equal to 10 to the fourth. So all I have to do is type that in the calculator or know how to do it in my head, either way. And I will find that 10 to the fourth is equal to 10,000. So that is my value for x. And then last but not least, we're looking here at number 5. It says the log base 81 of x is equal to 0. So how do I get from 81 to x? How does 81 become x? Well, I raise 81 to the 0th power, and that gives me x. So once again, I kind of locked out. I get x by itself is just equal to this numerical expression of 81 to the 0, and anything to the 0th power is 1. So that simplifies to 1 equals x, and that is in fact my answer. So at this point, you should feel confident both knowing what a logarithm is, converting between logarithmic and exponential form, as well as solving logs.